Hello, everyone. Good morning or good afternoon, depending on what time you're watching this video. It's me, Teacher Kent, and today we're going to learn about series and parallel circuits. Last time we talked about a simple electric circuit. Do you still remember that? Here, to remind all of you, this is an example of a closed and an open circuit. The difference is the switch is turned on in the closed circuit or the complete circuit. It means that electricity is moving. It's currently moving. There's both positive and negative electricity. And we have open circuit in which it's open. It's not complete yet. There can be no electricity because there's only one charge going around. For there to be for there to be electricity, there should be negative and positive. Let me make my video a bit bigger. There you go. And we're going to talk about the two types of electric circuit. The first type, the series electric circuit and the parallel electric circuit. So, what is a series electric circuit? It's an electric circuit that only has one path of electricity to flow. It only has one way. It only has one road for electricity to be able to move. If more bulbs are added to the circuit, the light becomes a bit dim. Dim means darker, or the light will not be very bright if there is more than one. Every time you add one bulb to the circuit in the series, the overall bulbs will lose a bit of their light. Next, if one bulb, only one, is broken, the other one will not turn on too. It will also not turn on. Now let's go with a parallel circuit. Wait, this is not a parallel circuit. I'm sorry. This is a series circuit. Okay, this is a series circuit. Okay, look here. It's a series circuit because, let me just find the pen here. There are two bulbs here and here. But there's only one direction for the electricity to flow, like that. If this bulb does not turn on, it means there is no electricity that is gonna go to this bulb, which means this one will also not turn on. Do you understand? Again, if this bulb does not turn on, this bulb will also not turn on. You know why? Because the positive energy and the negative energy, they do not meet. The protons and the neutrons, they do not meet. In order for the light to turn on, there should be a positive and negative charge here and here. If this one will block it, this one will not get any same electric currents. Do you understand? Again, this is a battery. Battery has positive and negative terminals. Each terminal carries one charge. Positive, the other terminal carries negative. They will meet here on the bulb. The bulb will turn on if there is both positive and negative. Without positive, without negative, they will not turn on. And If one of them will not turn on, the other one will also not turn on. It's because this part right here, this is where the other one, the other type of energy will move. And if this one does not pass the other energy, this one will also not get the other energy. That's why it's a series. Series means that there's a continuation. If one does not, there is no two if there is no one. You count one, two, three. There is no three if you do not count one. You do not say one and three. You need to go to two. So if there is no two, there is no three. That's why it's series. Now, let's go to the next type of electric circuit. This is called a parallel electric circuit. Again, this is called a parallel electric circuit. It's an electric circuit that has more than one path for the energy to flow. It has more than one path for the energy to flow. If more bulbs are added to the circuit, the light of the bulbs will stay the same. Okay, the difference between a series and a parallel is that the parallel has a lot of ways, a lot of areas where electricity can flow. It does not need to be only one. It can have two or more. Another difference is if more bulbs are added to the circuit, the light of the bulbs will stay the same because they do not pass another bulb. Let's go back a little bit so you can see something. Because this, where is the pen? Because let's say this bulb has, this terminal has like 10 volts. For example, when this one uses energy, if this uses energy, let's say it uses 2 energy, 2 volts. This one will have 8 volts left. This one will have less volts than this one. That means that the light, every light you add will decrease the volts. It will decrease the light, how the light shines. That's another thing about the series. It will decrease everything. Now, the parallel circuits. If more bulbs are added to the circuit, the light of the bulbs, they will stay the same. There's no change. If that area has 10, the other one has 10. I will show you later. Don't worry. And the most important one, if one bulb, only one bulb is broken, the other bulbs will still light up. Again, if only one bulb is broken, the other bulbs will still light up. This is a parallel electric circuit. Look at the picture. This is a series. This one is series, and this is a parallel. Look at the parallel. It has two ways for electricity to flow. Look, if it flows here, it will continue flowing here. But this part right here, it's another way. It's another direction. It's another road. So this one, go up here. There will also be a part right here. So what will happen? We already know that electricity needs positive and negative charges to turn on or to make an object activate. If this one, for whatever reason, does not turn on, it's okay because this one doesn't need the electricity, the charge from this one, because it has its own way. It has its own direction. Do you understand? Basically the difference between a parallel and a series one is it has more, it can accommodate or it can carry turn on appliances based on the different paths for it to move. There are two paths now, not just one. So even if the first path cannot be used, there is another path. For example, imagine you have a car. There's only you go you need there's only one turn left. So you can only go to the left. But in the if you have left and right turn, you can go to the left or to the right. You can go if the left is broken, you can go to the right. That is the difference between series and parallel circuits. Oh, we don't have time for video. So basically that's it. And parallel circuits, by the way, they are used in our houses so that when one turns off, the other appliances can still turn on. Did you learn something today? Well, I hope you did because you know what? Next next time we're going to have a review. We're going to have a review on simple electric circuits, all of it. Okay, I'm going to stop sharing now and I'll see you later. Goodbye.